Okay, welcome guys to the 2021 question C1 on geological geometry. So we've got a river there, ABC. Here we go. So take a moment there to just read through that. So we've got a portion, alright, circular portion, circular curve AB, and we've got A to C is level at an altitude of 95 meters. C to D is falling, so it's from C is the high point uniformly to a level of 90 meters at D. So C is at 95 meters and D is at 90 meters. So using side slopes 1 and 2 for the cuttings, and 1 is the 1.5 for the embankments, complete the necessary earthworks to accommodate the river on the northern side. So the southern side is already done. Okay, so the southern side, well, that's an embankment there. Okay, this is a cut. There's the numbers are above the altitude of the roadway. This is an embankment here again. Okay, and that's a cut. Now, so we'll begin, right? So for the embankment, the ground contours are 5 meter contours. So if we go out, or if we go down 5 meters, we are going out 7.5 meters. 7.5. So the lines, okay, on our sheet will be 7.5 apart. Now if we're going out 5 meters for cuts, we're going, or sorry, if we're going up 5 meters, so I'm just going to redraw that. Just do it here where there's a bit more space. So if we're going up 5 meters, we're going out 10 meters, because the cut slope has a slope of 1:2. So that's it. Now I'm going to start, okay, with the curved section from B. Okay, so I'll have some as a cut. So B is at 95, and I'm going to have 105, okay, 110 and 105 and 100 there. So here we go, that's at 100, okay, that's at 105, and this is at 110. So I'm going to take my compass, put it on O, and I'm going to rotate around there. So here's 100. Sorry, no, I'm not going to hit the 100 there. So out here's 100. Okay, here's 105 and 110. And there's 95. There's the 95. Now, so over here is going to be an embankment. So I'm going to do the embankment. I'm going to draw a line from the center point through the point, just so I don't get mixed up marking numbers there. Now they're every 7.5 mil apart. So what you can do there, right, is you can draw a line. So to mark in the 7.5s, what I do is, okay, up here you can mark a line 15 millimeters long. So I bisect the line. That's here 7.5. So that's at 90. Okay, 85. Okay, 80. That's all I need. So compass on O. Now there's 90, 85 and 80. So I can mark them in. There's an embankment. Here are some of the points here in the cut. And then from B to C is going to be a straight section. So I'm going to go parallel to the edge of the roadway here from 100. So there's the 100 point, and that's all. I don't need to go any more there. There's C. So I'm going to freehand sketch these in. Okay, now we're ready for the slope roadway. Okay, or the slope river edge. Sorry, I keep calling it a roadway. So if you look here, there's going to be an embankment and a cut. So there's a cut down here, an embankment up here. So D is at the lower end at 90. C is at 95. So I'll do the embankment first. So for an embankment, the cone always goes at the higher end. The cone goes at a higher end, and the base is level with the point you're using. So it's 1 unit, 5 meters. So the radius of the cone is 7.5 meters because the ratio is 1:1.5, and then the lines will be 7. Then the lines then will be 7.5 apart. Then, because they're in every 5. So I'm going to take my compass. Okay, set the radius to 7.5. So draw it in there. Then, okay, just drawing the tangent. I want to bisect the line nice and lightly. That's probably too short, that compass. Yeah, so I'll redo that. So I'll do it on the bottom. Point. There we go. So there's the base of the cone at 90 meters, lower end. Now, then we can draw our normal in here, okay, and we'll be stepping 7.5s, okay, along that. And then we might need one underneath. We will need one underneath, and that's going to be going from point C because the radius is 7.5. So there we go. Now that's at 90, Okay, 85, 80. So I can bring this to the two 80 contours. 85. So there's to the 90 contour, and there's 95. So I can freehand sketch them in together and do them lightly, as they're going to be heavied in later. Now there's another 91 there. Okay, the cut. So for a cut, the cone goes at the lower end of the roadway, or the river, and it's a slope of 1:2. So the vertical height between D and C is 5 meters. Okay, that's the vertical height between the C and D, 5 meters. So I sub that into the ratio of 1:2, so that would leave a radius of the cone 10 meters. So you have to check the vertical height. Okay, and that's 5 meters, and sub it into the ratio. Right, so we're going to set our cone to a radius 10 millimeters. And we're going to swing from D Now we're going to join C to the base of the cone as a tangent. So we're going to plot our lines 10 millimeters apart. So the base of the cone is at an altitude of 95, so that's 95, 100, 105, and then there's no 110 down here, and we're going to need to do one below at 90. So here's the 105, these 2 points, the 100, here's the 95, and 95 here, and then we need to do one at 90, for finding out where the embankment and the cut cross. Now we can freehand sketch those points in. And then where they intersect, okay, that's it there. Alright, so that's cut, that's an embankment. And then you can heavy them in. So I'll pause there and heavy them in. So that's them heavied in. Now, okay, part B, in the step diagram on the map, we've got the elevation and plan of 3 boreholes drawn from PQ in order to reveal the top surface of the stratum of ore at distance of 13, 15 and 10 meters from PQR respectively. There's no word or mention of the word altitude. So 13, 15 and 10 is what we're going to mark from points P, Q. So I'm going to mark 13 millimeters from P and 15 from Q and 10 from R along the lines. Now the only reason why I can do this, okay, is because the lines are true lengths in elevation. The skew boreholes are true lengths in elevation. The reason I know they're true lengths in elevation is the skew boreholes from P and Q, okay, they're parallel to the XY line in plan, So their true length and elevation. And then the skew borehole from or projects as a point in plan. So that means it's the true length in elevation. So that's why, so 15 meters from point Q. So this is 15 I'm marking. So that is why you can mark them directly just along them in elevation straight away. If they weren't, you'd have to find the true, rotate them until they're parallel to the XY line in plan, and then in plan, and then get the true lengths and elevation, mark the lines along the true lengths and elevation, and then rotate them back. So there's the 3 points drawn in on the surface of the stratum. So I'm going to join them together. So this is the head wall of the surface of stratum that contains the ore. Now I want to get the plan view of them, so I'm going to just drop those points to plan. So I'm going to drop P to plan, Q to plan, and then I'm going to join them together. Now, part II says determine the strike and dip of the stratum. So the strike, is a level line on the surface. So I'm going to draw a horizontal line, in elevation, and where it from P, and then I'm going to where it hits line or Q, I'm going to drop that to plan. Now I'm going to connect them together. Right, so this is the strike in plan, and this is the true length. Because it's parallel to the XY line in elevation. It's parallel to the horizontal plane. Then to get the dip, I'm going to look along this strike line. Now the reason why I'm looking along this strike line is because it's the true length, and thus the surface if the strike rests on, will project as an edge. So I've projected parallel to the strike. I'm going to draw in my X1, Y1 line now. And now I'm going to take my heights from elevation. So I only need to do 2, get 2 heights for speed. So I'm going to take the height of R and Q. I'm going to take the height of R and Q. I'm going to draw them in. So there's the surface as an edge view. And the dip is the angle the surface makes to the horizontal plane. So this is like finding the true inclination of a surface to the horizontal plane in part A and B. They're the same concept. Now, here's the dip. The dip so it's about 20 degrees. So it is 20 degrees. Right, part II. The length of a borehole from P as it passes through the stratum. So it's hard to comprehend here, is 15 meters. It's hard to comprehend, saying it's 15 meters from point P, or point P on the stratum. I don't know what the marking's going to be like. If you went 15 from P or 15 from the point on the stratum. I'm interpreting it as 15 from P. So I'm going to set my compass to 15. So I'm going to set my compass to 15. So points 15, 10 meters. Or so this is 15. Oh, sorry, no, I got my compass. is 15 long, I know from earlier. So I'm going to mark 15 from P on the borehole. And that line is a true length, so I'm in elevation. So I'm going to drop that to the borehole in plan. So I'm going to call that D, D, D. And then I'm going to project parallel to the strike, because the head wall and the foot wall are parallel. So I'm going to project them. I'm going to take the height from elevation, and there we go. Here's the thickness. So I'm getting 11 meters thickness. Right, thank you.